Marco has put together a fabulous presentation for us today on Climate Change 101. With that, I want to pass it over to Marco, and thank you for your time, Marco, and being a part of this.
Yeah, I'm happy to do it. So just a little bit of background on me. I'm used to be a high school science teacher, and then I've also spoken about climate change, like at Flagstaff, at a city council meeting and that kind of thing. So that's why they asked me to do today's presentation. And I feel like the most important thing actually also is I am the father to two very young boys. I have a 1-year-old and a 3-year-old boy. And so I'm concerned about climate change, not so much for myself. We will absolutely see some very serious effects from climate change within our own lives, but it's our children's lives and future generations that we really need to be concerned for. So, first of all, I got a couple of demonstrations here. Climate Change 101, I'm sure you guys are somewhat familiar, at least, with the idea that putting carbon dioxide into the air is warming up our atmosphere. And that is because carbon dioxide is a greenhouse gas. Just like greenhouses can let you grow plants in the winter and everything because it traps heat. They're called greenhouse gases because that same greenhouse effect works from certain gases. The primary one that you usually hear about is carbon dioxide. Whenever we burn fossil fuels, that's creating carbon dioxide, which gets put into the atmosphere. So I have a couple of buckets here. This bucket is meant to represent greenhouse gases in our atmosphere, and this bucket is meant to represent carbon that's stored underground, and when we pull it out and burn it, becomes greenhouse gases in the atmosphere. So historically, like over the past several million years, the average concentration of carbon dioxide in the atmosphere has been 280. I have a little line down here demonstrating where we've been historically. Since the Industrial Revolution and we started burning tons and tons of carbon dioxide, we've been taking carbon out from underground and burning it and putting it into our atmosphere. And at this point, as of this morning, I checked what the concentration is today, we are up to about 416. So 280 parts per million is kind of the Earth's normal. We have raised it from 280 to 416. That has resulted in warming of just over 1 degree Celsius. We're at about 1.1 degrees Celsius of warming so far, which does not seem like a big deal, right? If the temperature in the room you're sitting in were to increase by 1 degree, you probably wouldn't even be able to feel it. So it doesn't seem like this is too big of a deal. But the problem is that a lot of people are not familiar with the concept of climate change feedback loops and tipping points. So that's the main thing that I want to talk about today. What we've done has not had a huge effect up to this point, but it could trigger these feedback loops that could make things get much, much, much worse. So I created a video about this. I think just sharing that video is going to be the best way to get as much information across in a timely manner as possible. So let me play some of this video here real quick, and I will jump in and come back. Also, one thing to note is those people that don't know about feedback loops and tipping points, learning about them for the first time can be pretty daunting, even like arguably scary. I promise I will end this on a hopeful yay Earth Day type note. So apologies if this is a downer at first. We'll get back to the happy.
Hey everybody, so this article that was just published in the journal Nature a couple of weeks ago does a great job of summarizing the terrifying severity of the climate crisis. Politicians and economists and even some natural scientists have tended to assume that tipping points in the Earth's system, such as the loss of the Amazon rainforest or the West Antarctic ice sheet, are of low probability and little understood. Yet, evidence is mounting that these events could be more likely than was thought, have high impacts, and are interconnected across different biophysical systems, potentially committing the world to long-term irreversible changes. In other words, this is looking likely, and reaching just one of these tipping points, they're all interconnected, so that could lead to the tipping of another one and a domino effect that is going to have unimaginable consequences. If current national pledges to reduce greenhouse gas emissions are implemented, and that's a big if, they are likely to result in at least 3 degrees Celsius of global warming, and again, we get into the very high risk of triggering these tipping points just between 1 and 2 degrees of warming. So, what are these tipping points? Well, the easiest one to understand and visualize is ice collapse. Research in the past decade has shown that the Amundsen Sea embayment of West Antarctica might have passed a tipping point already. The grounding line where ice, ocean, and bedrock meet is retreating irreversibly. A model study shows that when this sector collapses, it could destabilize the rest of the West Antarctic ice sheet, toppling like dominoes, leading to about 3 meters of sea level rise on a timescale of centuries to millennia. 3 meters is about 10 feet, and to address the common misconception/conspiracy theory that melting ice won't raise the sea levels, that's if the ice is already in the sea. We are talking about ice that is sitting on land and melting into the sea. It absolutely will cause the sea level to rise by at least 10 feet, and it gets worse. The Greenland ice sheet is melting at an accelerated rate. It could add another 7 meters to sea level over thousands of years if it passes a particular threshold. That's another 23 feet of sea level rise beyond what we've already talked about. Models suggest that the Greenland ice sheet could be doomed at 1.5 degrees Celsius of warming, which could happen as soon as 2030. Thus, we might have already committed future generations to living with sea level rises of around 10 meters over thousands of years. But that timescale is still under our control, which is why we need to be taking action now. The rate of melting depends on the magnitude of warming above the tipping point. At 1.5 degrees Celsius, it could take 10,000 years to unfold. Above 2 degrees Celsius, it could take less than 1,000 years. Our current goals have us on track for 3 degrees Celsius of warming, which means we could see dozens of feet of sea level rise in less than 1,000 years. Again, that seems like a long time, but when we talk about climate change, we are not thinking far enough ahead. Even though we aren't going to be here to see it, how is it that we are not caring about what kind of environment we're leaving for our kids? Dozens of feet in less than 1,000 years? How much sea level rise will we see in 100 years when my kid will hopefully still be alive? Will there be any beaches left? How many coastal cities will be underwater? How many climate refugees will there be as a result? As they say here, action must be taken to slow sea level rise. This will aid adaptation, including the eventual resettling of large, low-lying population centers. Biosphere boundaries. Climate change and other human activities risk triggering biosphere tipping points across a range of ecosystems and scales. See Raising the Alarm, this graphic down below, which shows a bunch of different tipping points and how they are interconnected. For example, boreal forests, which is all of the forest fires that we've been seeing here in North America, and H, permafrost thawing, which is the scariest tipping point / feedback loop that I'll get to in a minute. Ocean heat waves have led to mass coral bleaching and to the loss of half of the shallow water corals in Australia's Great Barrier Reef. A staggering 99% of tropical corals are projected to be lost if the global average temperature rises by just 2 degrees Celsius. That will kill entire ecosystems, which are all interconnected. We're screwing ourselves here. Deforestation and climate change are destabilizing the Amazon. Estimates of where an Amazon tipping point could lie range from 40% deforestation to just 20%. About 17% has been lost since 1970. The Amazon tipping point could be as low as 20% forest cover loss, and we are currently at 17. With the Arctic warming at least twice as quickly as the global average, the boreal forest in the subarctic is increasingly vulnerable. Already, warming has triggered large-scale insect disturbances and increase in fires that have led to dieback of North American boreal forests, potentially turning some regions from a carbon sink into a carbon source. Plants take in carbon dioxide, right? So forests take in a ton of it, and the climate change is starting to cause them to die and burn, making them a source of carbon as well, instead of the thing that's supposed to be taking it out of the atmosphere. Permafrost across the Arctic is beginning to irreversibly thaw and release carbon dioxide and methane, a greenhouse gas that is 30 times more potent than carbon dioxide over a 100-year period. I mentioned that permafrost is the scariest one because it's frozen ground that normally never thaws out, but the 1 degree of warming that we've caused so far has made some of that permafrost start to thaw, and it's full of this organic matter that can then decompose and release methane, which again is 30 times more potent than carbon dioxide, which will cause things to warm up a lot more, causing a lot more permafrost to melt and methane to be released. And it's a vicious cycle, a feedback loop, a process that feeds on itself and can't be stopped once it gets rolling. And lastly, global cascade.
So, yeah, just to illustrate that a little more visually, the idea of a feedback loop, a process that feeds off of itself. Again, we're currently at about 416 parts per million of carbon dioxide in the atmosphere. There is about twice as much carbon stored in the permafrost as there is in the atmosphere currently. And so without really knowing it until relatively recently, we have also been causing some methane to start coming out of the permafrost, which I'm showing by sucking some of the water into this tube here. But so far, it's not become like a self-sustaining process, but we're getting pretty close to the point that it could become a self-sustaining process, like a siphon is what I'm creating here. If we reach a certain tipping point, then all of a sudden, this process becomes self-sustaining, and it will actually speed up over time, and all of the carbon that is stored in the Earth's permafrost is going to get released into the atmosphere, which would eventually triple the amount of carbon dioxide or greenhouse gas that we have in the atmosphere as compared to today. It's just a natural process. It's just like a siphon. If we let it reach a tipping point where it can just feed off of itself, there's not really any stopping it. So it is very important that we stop this process before it reaches that tipping point. Also, just another visualization for you of the kinds of rates that we're talking about. If this block represents the amount of greenhouse gas that we're putting into the atmosphere every year right now, and we were to not start decreasing that in the coming years, so say this is today, 2020, if in 2030 we're still producing the same amount of carbon emissions that we are today, then by 2040, it's projected that the permafrost would be releasing an equal amount or more of methane. And so all of a sudden our global emissions, our emissions plus the emissions of the permafrost, means that there are twice as many carbon emissions going into the atmosphere by 2040. So in just 20 years, the permafrost could be releasing as much or more carbon dioxide or greenhouse gas than we are now. And methane is a super potent greenhouse gas, and so this would just become an exponential thing. The methane would warm things up a lot more, which would cause a lot more permafrost to thaw, releasing a lot more methane, and it just goes and goes and goes until by the end of the century, one study projected that in 2100, if this becomes a runaway cycle, if it reaches its tipping point by 2100, it would be releasing about 6 times the amount of carbon dioxide that we are today. And by 2300, because again, I like to think much further into the future, like what are our grandkids going to have to be dealing with because of our decisions. By 2300, this, I don't know if that's even still in frame. It's right here. Yeah, this was, I think it's like 14 times roughly. Today's emissions is how much the permafrost would be releasing at that point. I mentioned that there's about twice as much carbon stored in the permafrost as there is currently in the atmosphere. So theoretically, it could triple the atmospheric concentration, but that would, granted, take tens of thousands of years. Just like kind of with the ice melting, I was talking about how we're more or less signed up at this point. Like, even if we were to stop all carbon emissions today, we have passed and are probably reaching certain tipping points for certain ice sheets that it would eventually result in about 32 feet of sea level rise. But again, that is over a very long time period, hopefully, depending on what we do now. If we do our part now, do everything that we need to do, then that 32 feet of sea level rise will still occur, but it will occur over like 10,000 years, giving us plenty of time to adapt to the situation. Whereas if we don't do our part and we just stay business as usual, or even worse, like continue accelerating our emissions like we have been for centuries now, then yeah, rather than that taking 10,000 years, it could take less than 1,000, and that's pretty scary. But promise to kind of like end this on a bit of a hopeful note here. We have not reached these tipping points just yet. Greta Thunberg, Time Person of the Year this year. I'm guessing most people that are tuning into this kind of thing know who she is. Kind of famously put out this graph showing that the carbon budget that we have remaining, like how much carbon we can still put into the atmosphere and hopefully avoid these tipping points. At our current level of use, we have about 8 years. So there's not much time left. We have about 8 years, it looks like. If we were to continue at our current emission levels, we would use up that budget within 8 years, at which point there would be a 50-50 chance of triggering these tipping points. So we're not there yet, but we are very, very close. And so it is absolutely imperative. Like, this is gonna be a long process. Like, 8 years should hopefully be enough time, as long as everyone starts taking this as seriously as they need to. But yeah, we need everyone to start taking this as seriously as possible, because yeah, we got to get this turned around in kind of less than a decade here. If people had taken this more seriously, so that 8 years, basically we can reach that goal. We can fix what we need to do if we lower our carbon emissions by 15% every year from here on out. So that's actually not too terrible. Like, that is a big ask, but also, like, if you consider the amount of emissions that we had last year, if you consider that 100%, we need this year to be 85% as much, and so on. So just if we incrementally reduce it by 15% per year, we'll be fine. That is possible. That is very hard. We need everyone full buy-in and everything, but it is still possible. We just need to commit. So yeah, we had talked about me presenting for about 20 minutes, which we've kind of reached at this point. And then I am happy to answer any questions if there are any.
Thank you, Marco. That was awesome. With messages like what Marco and others are helping to get out, it helps to bring awareness to all of us that now is the time to make a change, to make a difference, and we can all play a part in that. So with that, yeah, we've got about 22 participants on this. I see Sue online. Did you have a question, Sue?
I don't have a question so much as just wanted to say thanks to Marco, because and there's people on who are listening in who can verify this, that I am I don't even know what the word is, completely an idiot when it comes to science and math. And I just want to commend you for your presentation, because I got it.
Yay.
That's just alone an amazing thing that I understood. So thanks for not only giving really good information, but from my perspective, giving it in a way that people like me can really understand, and it becomes so relevant when it's in a conversation that you can get.
In closing, just again wanted to thank Marco helping to lead us as an organization and us as a community and to making positive changes. And just wanted to again thank everybody for tuning in to our virtual Earth Day